few questions takes us back to chapter R when we were first starting to remind ourselves how to do factoring. The first step in factoring, no matter what the problem is to pull out the GCF. If there's a common factor, you want to bring that out. So 28 and 63 have a common 7. Do you see that? You can factor 7 out of each of those. There's not a common x, though, like you might expect, because we're not used to maybe doing x to the 4th factoring, but it works out. But again, you cannot factor out x, it is not common, just 7. But what you see, you get here is the difference of perfect squares, and we have talked about the difference of squares. So the 7 just hangs out on the front, and then the square root of each of these would be 2x squared and 3, one with a plus, one with a minus. Notice that 2x squared times 2x squared would be 4x to the 4th. The last would be negative 9, and the inner and outer outers would drop out because they're the same, the different signs. 7 just hangs out. You cannot factor that any further. There's no way to break those down, so that is your answer. First step is the same, GCF. So always remembering in factoring that you want to pull out the GCF first step. So 81 and 192 aren't numbers that I'm overly familiar with, so I'm going to have to think a little bit about what you can factor out of those. But you might look at your answers, your choices, since it is a multiple choice test, and say, a lot of those have a 3 out. I bet 3 will factor out of these, and it does. You can pull out a 3 from 81 and 192. Also, there's a common ilm to the first and ilm to the 4th, so you can bring out one of the ilms. So that leaves 3 times 27 and a k to the 3rd to get this answer. 3 ilm times, let's see, what is that, 64. You've got ilm to the 1st, so you need ilm to the 3rd to make ilm 4. So by factoring out the GCF, you get another one of those special patterns. Remember, if you have the difference of, well, like this one was the difference of squares. It made the square root plus and minus. But the cube pattern is kind of, it's different, very different pattern. But you do need to know your cube pattern. Okay, the 3 ilm that you factored out just sits on the outside. Then the cube root, the cube pattern is you take the cube root of each of these, 3k and 4 ilm. Use the middle sign for your first parenthesis. So again, cube roots with the same sign. Then the pattern says to square this root, so that would be 9k squared. Multiply these together, so that's 3k, 4 ilm makes 12k ilm with an opposite sign, so plus 12k ilm, and square the last, plus 16 ilm squared. And then we're guaranteed that this cube pattern does not factor on any further. That is the end of the line for that, so that's your answer. Okay? Multiply together.
Okay.
Yeah, that comes from your roots multiplied with the opposite sign. These two signs will always be different. So if it's minus, that's plus, and multiplied together. So square, multiply together with a different sign, and square. And number 3 is a lot of factoring as well. It is a division problem, so I'll go ahead and change it to multiplication by flipping the second fraction. Notice it says divide, so I'm timesing by the reciprocal. All right, then the big deal back in chapter R, what I kept aggravating you with is I would say you cannot cancel if there's a loose plus or minus sign. You cannot cancel in that form. You have to factor it first. So each one of these factors in some way. This is the basic unfoiling, the reverse of the FOIL method. Notice that could be checked. This one as well. This one as well. And then the oddball of the group, this does not have that third term. It's not your traditional just reverse of the FOIL method. It has a GCF. And so remember what I said earlier. Always factor out the GCF if there is one, and sometimes that's as far as it goes, like there. Okay, Once you get everything factored, then you're going to cancel diagonally or vertically any common matches, any common factors. So I can do the plus 6's, this vertical x plus 5, a diagonal x plus 7. So all that's left is the top z plus 3 over z for your final answer. Now, I will say this also about the final, or not the final, but the midterm, is in a lot of cases, the questions are much easier on the final exam to say, on the midterm exam, to save time because a lot of these problems are very lengthy, and so the exam questions are short. And also the thinking is you get more power per problem if you really have to work through something like number 4, worst case scenario of adding and subtracting the fractions. You know it very well, and then you might have a simpler question on the final like it. But anyway, this one really puts you through it, trying to figure out what the LCD is. You know, you can't just pick out the LCD if you've got this stuff that needs factored. You have to do that first. So each one of these denominators get in factored form. Notice none of these had a GCF. You know, wish it would have. It made it easier, but there were no common factors in any of those terms, so it was ready to go with factoring. This is 4r plus 2s. No, it's not. It's 4r plus 1s. And 1r minus 2s. The middle one factors into 6r minus 1s and 1r minus 2s. The third fraction would be 6r minus s and 4r plus s. So you have to get it to where you can see the LCD. You know, sometimes you have fractions where it's just monomials in the denominator and you can just kind of look at it and say, what do they all fit into? But if you have these plus and minus sets, trinomial sets, you have to factor it first. Then the LCD is one of each factor where it's at the most. So you need one of each thing. I need a 4r plus s, r minus 2s, 6r minus s. I've already got that, and I've already got that. So one of each thing, and then if it would be repeated, if I would have 4r plus s twice, I would need 2 of them here for that to fit into. The idea is LCD means all of those fit into it. All right, then you have the task of rewriting your numerators. Okay, so now we're going to rewrite our fractions with these new denominators, because you know you're not allowed just to change what it looks like without making amends for that on the top. You have to do the same thing to top and bottom. So the new part here is 6r minus s, so also times the top by 6r minus s. What's new here is, let's see, 4r plus s, so also times the top by 4r plus s. And then lastly, the new part is this middle part, so times the top by that. We've kind of been out of the practice of that because in chapter 1, we moved away from this. We would times through by the LCD and kind of just wipe out our fractions because we had the 2 sides of the equation to work with. But not back in chapter R. There's 3 fractions that you combine. Okay, so you still with me? Big deal here is, after you do all of that work, it would be a shame to miss it because you forgot to pick up your negative signs, and that happens so often. People say, I dropped my negative. No. So make sure you don't do that. This -6 distributes, and that changes the whole answer if you don't do that. So anyway, distributing the 2, that's safe. This is what worries me. Distribute the negative sign as well. Makes it minus 24r and minus 6s. Then lastly, distributing a positive 9. And now all of that is over our common denominator. combine any like terms in the numerator. So 12R minus 24R and a 9R combines to be what? Negative 3R, I think. And then negative 2S, negative 6S, and negative 18S combines to be negative 26S all over that common denominator. So that step was just simplifying the numerator. And it's kind of traditional to leave the answer, if you've noticed so far, to leave the answer in algebra with the denominator in factored form, but the numerators multiplied together and simplified, and that's usually just standard form. So that would be how we'd leave it. One other thought, just in case this would happen on your exam, they all generate out differently, you know, and this is always a thought for us. If you can reduce it, you should always reduce. If this was a matching set to one of these, we would cancel out. If there was some way I could factor that, I would try to factor it and get a matching set to cancel out. So always be on the lookout for that. Is there any way to reduce it? But 3 and 26 have no common factors, R and S, so that does not reduce. You want to pause it there?